Hey guys, today we're going to do a little more linear programming. Our objective is to use linear programming to maximize profit. So here's our problem for today. As a receptionist for a veterinarian, one of Dorothy's tasks is to schedule appointments. She allots 20 minutes for an office visit, 40 minutes for a surgery. The vet cannot do more than 6 surgeries on a given day. The office has 7 hours available for appointments. Should say appointments there. If an office visit costs $55 and surgeries cost $125, find the combination of office visits and surgeries that will maximize the income the vet practice receives per day. Okay, so we're going to let X be the number of office visits, Y will be the number of surgeries, and we've got some situations down here that we're going to write inequalities for. The number of office visits and surgeries cannot exceed a total time of 7 hours. So it takes 20 minutes for just a basic office visit. So 20 minutes times X plus 40 minutes times Y, and that has to be less than or equal to 7 hours. Now these are both in minutes, so let's turn that 7 hours into minutes. So there's 60 minutes per hour times 7 hours. 420 minutes is our total amount of time. So 420. Now we need to turn that into slope-intercept form so we can graph it later. So let's just do that now. So we'll subtract that 20x. 400y is less than or equal to negative 20x plus 420. Okay, let's divide everything by 40. That shouldn't say 400 there, that should say 40. So we'll divide everything by 40. So we're going to get y is less than or equal to negative 1/2 x plus, and then 420 divided by 40 is 10.5. Okay, so that's our first equation. The number of surgeries cannot exceed 6 per day. So surgeries was y. Y has to be less than or equal to 6. The number of office visits can't be negative. You can't have negative people coming in for a basic checkup. So X is greater than or equal to 0. You also can't have negative surgeries, so Y is greater than or equal to 0. Okay, so we're going to graph that system of inequalities, and we'll find the feasible region. Okay, so our first line was y equals negative 1/2 x plus 10.5. Okay, so let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, and I'm going to do the same down here. Okay, now let's label each axis. So the x-axis was the number of office visits. The y-axis was surgeries. Okay, so we had a y-intercept of 10.5 and a slope of negative 1/2. So that's down 1 and right 2. Okay, Our next line is y is greater than, or I'm sorry, y is less than or equal to 6. So that's a horizontal line right here. Okay, now I didn't shade for that first one. I'm going to go back and do that. So if I put in the origin here, I get 0 is less than or equal to 10.5, and that is true. So this one is going to shade toward the origin. The next one, y is less than or equal to 6. If I plug in the origin, I get 0 is less than or equal to 6. That is true. So again, I shade toward the origin. Okay, so right now it's this area that's been shaded both times. Then I have x is greater than or equal to 0. That's a vertical line right here. And I can't test the origin because the origin is on the line, so I'll test 1, 1. If I put in a 1 for x, I get 1 is greater than or equal to 0. That's true, so I'm going to shade toward 1, 1. And then y is greater than or equal to 0 is a horizontal line right here. Okay, and if I plug in 1, 1, I get 1 is greater than or equal to 0. That's true. Now I never got an intersection out here, so I actually need to figure out where these are going to intersect. So I'm going to go down 1 and right 2 again. So that's going to be right about here. Okay. Now if I just go down a half, I would go right 1. So that's actually going to be right here. That's where they're going to intersect. So I've got 16, 17, 18, 19, 20. So it looks like they're actually intersecting at 21, 0. Okay. So what got shaded all 4 times is this region right here. So that's the feasible region. The vertices, I've got 0, 0. I've got 0, 6. Right here, I'm at 9, 6. And then way out here, I'm at 21, 0. So the X's are my number of basic office visits. The Y's are the number of surgeries. So one of those 4 combinations will maximize our income for each day. Okay, so write a formula for the profit. Should actually just be the income, since we're just talking about income here. So for our income, we are going to get $55 for every office visit and $125 for every surgery. So that's 55x plus 125y. Okay, and last is we're going to try to find our maximum income. It says profit here, but we actually don't know the costs, so we're just going with income for this. Which vertex is going to give you the maximum value, and what will be the income? How many should we schedule of each? And that'll be based on what gives us the best income. So our x's and y's, our income expression 55x plus 125y, and then our total income. Okay, so for our x's and y's, we had a point of 0, 0. So if we do 0 of each, 55 times 0 plus 125 times 0, we're not going to have any income, so that's not a good idea. Okay, our next point, we had 0, 6. Okay, so that's 55 times 0, so no basic office visits, plus 6 surgery, so that's 125 times 6. And that's 750. So we'll have an income of $750 that day. Okay, if we do 9 regular office visits and 6 surgeries, that's 55 times 9 plus 125 times 6. That's $1,245. Okay, and our last option was 21 regular visits and 0 surgeries. So that's 55 times 21 plus 125 times 0. And that's $1,155. Okay, so if we're going to maximize our income for that day, that's our highest income. So we should be doing 9 office visits and 6 surgeries. For $1,245 income.